Welcome trainees. Today, we are going to learn about the topics related to grinding wheel. We are directly go for the introduction of grinding wheel. A grinding wheel is a wheel composed of an abrasive compound and used for various grinding, abrasive cutting, and abrasive machining operations. Let's see the objectives of this topic. You shall be able to state the factors influencing grinding wheel, state the specification and selection of grinding wheel. Let's see the factors influencing for grinding wheel selection: abrasive, grade, structure, and bond. First, we can see the definition for abrasive. A grinding wheel consists of the abrasive that does the cutting and the bond that holds the abrasive particles together. After the definition, we can see the types of abrasives. There are two types of abrasives. First is natural abrasives, and the next is artificial abrasives. Now see the first type of abrasive, that is natural abrasive. The natural abrasives are emery and corundum. These are impure forms of aluminium oxide. And the next type is artificial abrasive. Artificial abrasives are silicon carbide and aluminium oxide. Next, we are going to see how to select the abrasives. The abrasives are selected depending upon the material being ground. Brown aluminium oxide is used for general purpose grinding of tough materials. White aluminium oxide is used for grinding ferrous and ferrous alloys. Green silicon carbide is used for very hard materials with low tensile strength, such as cemented carbides. Now, we can see the second factor influencing for selection of grinding wheel. That is grade. Grade indicates the strength of the bond and, therefore, the hardness of the wheel. In a hard wheel, the bond is strong. In a soft wheel, the bond is weak. The degree of hardness possessed by the bond is called the grade of the wheel. The next factor influencing for the selection of grinding wheel is structure. This indicates the amount of bond present between the individual abrasive grains and the closeness of the individual grains to each other. An open structure wheel will cut more freely. It will remove more metal in a given time and produce less heat. It will not produce such a good finish as a closely structured wheel. And the last factor is bond. The bond is the substance which, when mixed with abrasive grains, hold them together, enabling the mixture to be shaped to the form of the wheel, and, after suitable treatment, to take on the necessary mechanical strength for its work. Let's see about types of bond. There are several types of bonding materials used for making wheels. 1. Vitrified bond. 2. Silicate bond. 3. Shellac bond. 4. Rubber bond. And 5. Resinoid bond. The first one is vitrified bond. This is the most widely used bond. It has high porosity and strength, which makes this type of wheel suitable for high rate of stock removal. It is not adversely affected by water, acid, oils, or ordinary temperature conditions. The second one is silicate bond. Silicate wheels have a milder action and cut with less harshness than vitrified wheels. For this reason, they are suitable for grinding fine edge tools, cutters, etc. The third one is shellac bond. This is used for heavy-duty, large-diameter wheels, where a fine finish is required, for example, the grinding of mill rolls. The fourth one is rubber bond. This is used where a small degree of flexibility is required on the wheel, as in the cutting of wheels. And the last one is resinoid bond. This is used for speed wheels. Such wheels are used in foundries for dressing castings. Resinoid bond wheels are also used for cutting off. They are strong enough to withstand considerable abuse. Next we are going to see how to specify a grinding wheel. A grinding wheel is specified by the standard wheel markings, like diameter of the wheel, bore diameter of the wheel, thickness of the wheel type, shape of the wheel. Example: 51 A, 36 H, 5 V, 40. 250 into 20 into 32 straight wheel. After the specification, let's see how to select the grinding wheel. If a wheel is specified as 500 into 20 into 127, BA 60 L 5 V3. For this, 500 denotes the outer diameter, 20 denotes the thickness, 127 denotes the bore, BA denotes grain type, brown aluminum oxide, 60 denotes grit size, L denotes hardness, 5 denotes porosity or space, V3 denotes bond type. By this way, we can select a grinding wheel. Now see the uses of a grinding wheel. The abrasive grains provide the wheel with its cutting ability, which helps in finishing the material to the required dimensional accuracy and surface finish. For the remembrance of this topic, we are trying to answer one question. The question is: what type of abrasive is used for grinding ferrous and ferrous alloy? The options are A. Brown aluminium oxide, B. White aluminium oxide, C. Red aluminium oxide, D. Green silicon carbide. The answer is B. White aluminium oxide. After the specification, selection, and use of grinding wheel, we are going to discuss about grinding wheel mounting and dressing. Let's see the objectives of this topic. You shall be able to state the grinding wheel mounting procedure, state the purpose of dressing, state how to use grinding wheel dressing. First, go for the grinding wheel mounting. For correct and safe operation of a grinding machine, it is essential to mount the grinding wheel correctly on the spindle. Before fitting a new wheel, make sure that the spindle is completely clean and free from surface irregularities. Let's see the mounting procedure. The below steps shows how to mount the wheel on the spindle of the grinding machine. Step 1. Check that the spindle surface is clean and free of irregularities. Clean with a dry cloth, if necessary. Step 2. Check that the inner flange is fixed to the spindle and that its bearing surface is clean and true. Step 3. Check that the wheel bush surface is clean and that it can fit easily, but not loosely, onto the spindle. Clean the bush before fitting the wheel on the spindle, if necessary. Step 4. Check that each side of the grinding wheel is fitted with a soft paper disc of slightly larger diameter than the spindle flanges. Step 5. Check that the diameter of each spindle flange is at least 1/3 the diameter of the grinding wheel. Step 6. Fit the grinding wheel to the spindle and place the outer spindle flange in position. Step 7. Tighten the spindle nut against the outer spindle flange with a spanner of the correct size. Step 8. Replace the wheel guard correctly. The next one is grinding wheel dressing. The purpose of dressing are: restore the correct cutting action of the wheel, removes the clogs on the surface of the wheel and the blunt grains of the abrasive, exposing the new sharp abrasive grains, which can be cut and brought to shape efficiently. Let's see the types of grinding wheel dressers. The wheel dressers used for offhand grinders are: star wheel dressers, Huntington type wheel dresser, diamond dressers, abrasive stick. First one is star wheel dressers or Huntington type wheel dresser. The star wheel dresser consists of a number of hardened star-shaped wheels mounted on a spindle at one end and a handle at the other end. While dressing, the star wheel is pressed against the face of the revolving grinding wheel. The star wheel revolves and digs into the surface of the grinding wheel. This releases the wheel loading and dull grains, exposing sharp new abrasive grains. The second type is diamond dressers. Bench type of hand grinders, used for sharpening cutting tools, are usually fitted with smaller and rather delicate wheels. These wheels are dressed and trued with diamond dressers. Diamond dressers consist of a small diamond mounted on a holder, which can be held rigidly on the workrest. The other type is abrasive stick. When only a light dressing is required, abrasive sticks can also be used. There are abrasive materials made in the form of sticks for the convenience of handling. After the types, we are going to discuss about how to use a wheel dresser. For dressing and truing, the dresser is slowly brought into contact with the wheel face and moved across. The finish obtained depends on the rate at which the dresser is moved across the face. For roughing, the dresser is moved faster. For fine finish, the dresser is moved slowly. This is how we can use a dresser. For the remembrance of this topic, we are trying to answer one question. The question is: what is the name of this dresser, given below? The options are: A. Diamond dresser, B. Abrasive stick, C. Star wheel dresser, D. Metal dresser. The answer is C. Star wheel dresser. After the grinding wheel mounting and dressing, the next topic is bench grinders. Let's see the objectives of this topic. You shall be able to state the features of bench grinder, State the parts and uses of bench grinder. Let's see about offhand grinding. Offhand grinding is the operation of removing material which does not require great accuracy in size or shape. This is carried out by pressing the workpiece by hand against a rotating grinding wheel. Offhand grinders are fitted to a bench and pedestal. Now discuss about the bench grinder. Bench grinders are fitted on a bench or table and are useful for light duty work. These grinders consist of an electric motor and the spindle for mounting the grinding wheels. On one end of the spindle, a coarse-grained wheel is fitted, and on the other end, a fine-grained wheel. For safety while working, wheel guards are provided. The next discussion about parts of bench grinder. The parts are a coolant container, wheel guards, adjustable work tool rest, eye shield, grinding wheel. Let's see the uses of bench grinder. Offhand grinding is performed for rough grinding of jobs and resharpening of scribers, punches, chisels, twist drills, single-point cutting tools, etc. For the remembrance of this topic, we are trying to answer one question. The question is, what is the part marked as X? The options are A. Wheel guard, B. Grinding wheel, C. Coolant container, D. Eye shield. The answer is D. Eye shield. With this, we are completed the topic of grinding wheel. I hope all are getting some information about grinding wheel. I will be back with the topic of gauges in the next PowerPoint. Thank you.